All right, so we continue with this. So this will be the input for f inverse, right? Because it's f inverse of that. So f inverse is the cube root of x cubed minus, so x, it's right there, cube root of x plus 2. So I'm going to put x and then plus 2. And my x is being replaced by x to the third minus 2. Okay, so when I simplify, this is the cube root of, and x minus 2 plus 2 will be x to the third, and the cube root of x to the third is x. Okay, f of f inverse of x will be f of, and f inverse is the cube root of x plus 2. All right, and f is x cubed minus 2. So it's whatever x the input is, and then cubed, and then minus 2. All right, and the input is the cube root of x plus 2. All right, so the cube root of x plus 2 cubed is just x plus 2. And then minus 2, x plus 2 minus 2 is x. And of course, f inverse of f of x should be x, and f of f inverse of x should also be x. Okay, so that was finding an inverse. And then finally, one-to-one functions. And what do these have to do with anything, right? Well, let's check to see what a one-to-one function is. So a function f is one-to-one if for c and d in the domain of f, that means they're x values, right? C and d in the domain of f, that means they're x values. C not equals to d, that means if the two x values are not equal, implies f of c not equal to f of d. So if the two x values are not equal, then the two y values cannot be equal. That means for different x's, you must have different y's. Okay, that means different inputs always result in different outputs. All right, there's a horizontal line test we can use for this. If every horizontal line intersects the graph of function f at most once, then f is one-to-one. So it could only intersect it once to be one-to-one. All right, so let's try number 1 and number 4. So number 1, notice here I can use the horizontal line test. The question is, determine if f is one-to-one. So I can see that some horizontal lines cross more than one place. So this is no. Okay. And over here for number 4, each different x has to give me a different y, and x equals 2 and x equals 3 give me the same y. Is that okay? So the answer is no. They have to give me a different y value. Different x's must have different y's. All right. And we will leave 2 and 3 for class. All right. So what does this have to do with inverse function? Well, a function f has an inverse f inverse if and only if f is one-to-one. So only one-to-one functions have inverses. All right. And also remember, f inverse of f of x is x, and f of f inverse of x is x. Okay. The domain of f is the range of f inverse, and the range of the domain of f inverse is the range of f. All right. A couple of examples we'll do. Determine if f is one-to-one. It may help to make a sketch of f. That means if necessary, and if you know what the sketch looks like. If possible, find f inverse and the domain and range of each. Okay. So let's do number. Let's do 5 and 6. Okay, so 5, is that one-to-one? Well, this is y equals 3x minus 1. That's a line with slope 3. Yeah, that means each different x gives us a different y because it's always climbing or always falling. All right, so this is one-to-one. This is one-to-one. One-to-one. And that means I have an inverse and I can find the inverse. So let's go through those steps again. First, replace y, f of x with y. Switch x and y. So this will be x equals 3y minus 1. Solve for y. So I'm going to add 1. So I'll have 3y equals x plus 1. Divide by 3. So I'll have y equals x plus 1 over 3. Okay, and then call y f inverse. So f inverse of x equals x plus 1 over 3. There we go. All right. Don't forget they have to be one-to-one. If they're not, then they don't have an inverse, and we can find the inverse. We cannot find an inverse. F of x equals the absolute value of x minus 2. This is the absolute value of x shifted 2 down. Remember the absolute value of x? It's the v, right? If it's shifted 2 down, it's like so. All right. It is not one-to-one because some horizontal lines cross it twice, so it is not 1, 2, 1. Therefore, it has no inverse. Okay. All right, and we will leave 7 and 8 for class. All right, and that is the end of section 5.